In this tutorial, we're going to cover not only what is one of the most common misunderstandings that novice and intermediate learners of Python have, the mutable default argument, but also how we can use this to our advantage to create memoization functions. Let's begin. We're kicking things off by defining a function whose intended role is to take an input value and return a list with the value appended to it. As a result, we have two parameters, the input value and a default empty list. In the body of the function, we return the list after having appended value to it. We want to have two variables, a and b. We should have a list containing 1 assigned to a and a separate list containing 2 assigned to b, right? Wrong. Both a and b point to the same list, and so both print 1, 2. Why does this happen? Default parameter values are always evaluated when the function definition is executed. When Python encounters your function definition, it executes it in order to create a function object that's then used when you call it. So our definition here created the object append_1, and it's this object that's then called when we wrote our assignment to A and then B. So this line assigns an empty list to _list, and the function appends 1 to it. The next line appends 2 to the same list. In fact, we can inspect a function's default values by accessing the _defaults attribute. The defaults are contained in a tuple. We only have one default in this function, so it's contained at index 0 of this tuple. How do we get the behavior we were originally after? Well, we can hack it by changing this list at index 0 back to an empty list. Alternatively, we could just define the function again, which would create a new function object with the original default that was an empty list. But this isn't really the right way to go about things, nor is it very practical. Instead, we assign a placeholder value, such as none, to our parameter. Then we create our new list within the body of the function. Now, every time our function is evaluated, a new list is created. Understanding how mutable defaults work does enable us to use it for valid use cases. For instance, memoization. Memoization speeds up programs by storing the results of expensive function calls. It's a form of caching. In order to demonstrate an expensive function, we'll go ahead and define a terribly inefficient Fibonacci sequence function. As you can see, n equals 25 is relatively slow, n equals 30 is much slower. N equals 35 takes far longer to calculate. We'll define a function memoization. It takes in n, which is the same n that we'll pass into our Fibonacci sequence function, and our mutable default is a dictionary assigned to memo. We first see whether this dictionary contains a value for the given key n. If we haven't encountered this n before, then we would get a key error, but we'll catch this key error, and it's only at this point that we'll attempt to call fib. Once we've worked this out, we'll place it in our dictionary with the key being n, and then we'll return the value. So now, when we work out memoization 35, it takes just as long as before. But now that we've seen these two values, when we attempt to call memoization 36 a second time, instead of sending for the Fibonacci function, we just look in our dictionary, which is relatively far less expensive and takes no time at all. And as we saw earlier, we can inspect the defaults of the memoization function object, and we can see that we have a dictionary containing the values for the ends that we've already seen. I hope you found this useful, and as always, I'd love to hear your feedback in order to improve the future content released on this channel. Take care.